So welcome to 6.7 trig ratios quiz. So before I start this, just so that you remember, when we're talking about trig ratios, we have to remember the two special triangles. So remember, the two special triangles are the angles, are the triangles that have angles 30 degrees or 45 degrees or 60 degrees. So if you recognize any of these, we have to use our special triangles, which means we always have to give exact values. Remember, if you have an angle that is not 30, 45, or 60, then that's when you want to use your calculator and give an estimated value. Okay, but whenever you see like 30, 45, or 60, although the question might not say get exact values, it is expected that you get the exact values. So let's just do a quick recap of what the special triangles look like. And you have to memorize these special triangles. If you forget, then make sure you remember how to actually obtain them yourself, okay? Because I will not be giving them to you on a test or the exam. So these two triangles, they all have a 90-degree angle. So I'm going to start by drawing two triangles with 90 degrees. So that's my triangle number one, and I'm going to have my triangle number two. So they're all going to have 90-degree angles. This one's going to be a 45 degrees, 45 degrees, 45 degrees. And the side lengths for these are going to be 1, root 2. And for this one, we're going to have 30 degrees as a smaller angle, 60 degrees. And we're going to have, remember, it's 1, 2, and root 3. The largest one is going to be 2, which is my hypotenuse. And whatever's across from the 30, because that's a smaller angle, that's going to be the smaller number. So 1, and then root 3, which is the number in between, that's going to be the one that's across from 60 degrees. Okay. You will, or you might need to constantly refer to these anytime you have a 30, 45, or 60. So sometimes it's a good idea if you just write these or draw these triangles down at the top of a page or somewhere so that you can make reference to the triangles. Okay. And now let's look at the first question. It says determine the exact value of sine 30 minus cos 45 times tan of 60. So we're going to be getting the fraction of values of these, and remember, because they're 30, 45, or 60, they must be exact values. So if it's sine 30, let's just go back to our triangle. So it's going to be 30 degrees with the sine ratio. So that's going to be this one. So if I do sine, so if I'm using this as an angle of reference, sine is opposite over hypotenuse. Opposite will be 1, hypotenuse will be 2. So sine of 30 is going to be 1 over 2. It's going to be 1 over 2. And minus cosine of 45. So if it's 45, I need to use the other triangle with the 45 degrees. So let's look at the triangle on the left. Doesn't matter which one you use as an angle of reference because they're both the same. The question was asking for 45. So 45, it's cos of 45. Cosine is adjacent over hypotenuse. Root 2 is going to be my hypotenuse. So cosine of 45 will be 1 over root 2. Down here, cosine is 1 over root 2. And it's going to be multiplied by, so I'm not going to use times symbol, I'm going to use brackets. And now it's going to be tan of 60. So again, let's go back to our special triangle. It's going to be tan of 60. So I got 60 degrees, and I want tan, which is opposite over adjacent. So if this is my angle of reference, this is going to be my opposite, the root 3, because I'm on the other side of 60. Beside a 60, that's going to be my adjacent side. So if it's tan of 60, it's going to be opposite over adjacent, so root 3 over 1. I'm going to get rid of that. Okay, so it's going to be root 3 over 1. That's going to be my tan of 60. It's going to be root 3 over 1. And now all you have to do is simplify them. So first, let's remember we got to do bed math. So we got to do multiplication first. So I'm going to keep the 1 over 2. It's going to be minus root 3 over root 2. All I'm doing is just multiplying these straight across. And Now with these ones, it's a fraction, so you can add them. But remember, whenever we're going to add fractions, we need a common denominator. And I'm going to have 2 as my common denominator, so I'm going to multiply the top and bottom of the right fraction by root 2 over root 2. And that's going to give me half stays the same. Root 2 times root 3, well, everything's under the root. 3 times the 2 is a 6. Root 2 times the root 2, and that's going to give me a 2. So now you just have to add the numerators, and I get 1 minus root 6 all over 2. And this will be my final answer. Okay, now let's look at number 2. So 0.5 and negative 12 lies on the terminal arm of an angle theta in standard position. It says draw a diagram of this information and clearly label the theta and the value of all sides of the triangle. So when we have to put this on the diagram, we're going to start with a Cartesian plane. We're going to label this x and y. And my point is going to be 5 and negative 12. So it's going to be positive on the x, so it's going to be somewhere over here, and then it's going to be a negative value of y, so it's going to come down, so it's going to be in the 4th quadrant. And I'm going to draw my terminal arm. So there's my terminal arm, and I'm going to draw my triangle. Remember, when we're drawing the triangle, always draw a vertical line. So I'm going to start from the 5 and negative 12. I'm going to draw a line. Never ever draw it horizontally, always vertically. I'm going to draw my vertical line. And because it's going to be vertical, it's going to be always 90 degrees to the x-axis. So I'm going to label that with a 90-degree angle. So now the x value is 5, so which means this value, so the length of this is going to be 5. That's going to be 5, and the y value is going to be negative 12. So, that's going to be the vertical line. So that's going to be this one. Oh, let me redraw. So that's going to be the length of 12. If you want, you can put in the negative now, but I'm just going to use the CAS rule and put in all the negatives later. So if you want to put in the negative 12 here, that's fine. You don't have to use the CAS rule if you do that, but I will use the CAS rule because I like to keep everything positive and then just apply the negatives at the end. But if you want to keep the negative there because that's what works for you, then that's also fine. Okay, but I'm just going to use a positive value. Okay, so draw a diagram of this information. So I drew the diagram, I drew the triangle, that's great. Clearly label the principal angle as the theta. Okay, so when we're drawing our theta, remember we always have to start from the positive x-axis. So that is this axis. So we're gonna start from the positive x-axis, and we always go counterclockwise. So from here, I'm going to go counterclockwise until we reach the terminal arm. Okay, so the distance between here to positive axis, from the positive x-axis, and as I go counterclockwise, this is going to be my theta. So that's going to be my theta, and this angle inside will be your beta. Okay, but it doesn't ask you to label the beta, so you don't have to do it. But it's asking you for theta, so this is going to be my theta. It's not this one, it's going to be this one. Positive x-axis, and you just go counterclockwise to the terminal arm. Okay, so we drew a diagram, clearly labeled the principal angle as theta, so that part's that, and the value of all sides of the triangle. We did that for the 5 and the 12, which are the x and y values, but we haven't done it for the hypotenuse. So the hypotenuse, because we're going to be rotating, like we always label this r. So label the hypotenuse as r, and we can use a Pythagorean theorem. So it's going to be x squared plus y squared, and it's going to be equal to the hypotenuse squared, which is going to be r squared. We have our x and y values. Here you can use either, so x value is going to be 5, and for 12, we can either use positive 12 or negative 12. It doesn't matter because everything's going to become positive with the squared anyways. So I'm just going to use just a positive because I use a positive here. But even if you were to use a negative, the negative would be gone anyways. Okay, and that's going to be 5 squared is 25, 12 squared is 144, that's equal to r squared. Oop, that r looks funny. R squared, 25 plus 144, that's going to give me 1 69 is equal to r squared, and r is going to be root of 169. Now, try to do 169 rooted, and is it going to give you a nice number? Yes or no? I know this one will. It's going to be 13. But in cases where it does not give you a nice number like 13, you got to leave it as a root. Keep your values as exact as possible. Don't round when you don't need to. But in this case, it's going to be a nice number, so my r value is going to be 13. Okay, so let's just write a little summary. You don't have to do this, but I'm going to do it anyway. So I'm going to say my x value is going to be 5, y value is going to be 12. You can put negative if you would like. And my r value is going to be 13. Remember, r value is always going to be 13 because whenever we're talking about the hypotenuse on or the r value, and when we have the triangle on the Cartesian plane, it's always going to be a positive value. Okay. Oh, but we haven't labeled the third side with 13, so to make sure you label, because the question is asking you to do that. So just make sure that all the parts of the questions are answered. So that should be it for part A. Okay, now B, it says determine the exact values of sine theta, cosine theta, and tan theta. So sine theta, cosine theta, and tan theta. So when you come up with this, you can think of it as opposite over hypotenuse, or like, you can think of SOHCAHTOA. That's usually what I do. Some people, they still, like they're comfortable with knowing that sine theta is going to be y over r, cosine is x over r, tan is y over r. But I normally don't always memorize this. Like if that works for you, then that's great. But I usually just stick to the regular SOHCAHTOA. So if we look at our diagram over here, remember we always make in reference to the beta angle. So if that's my beta, I'm just going to use that as a reference angle. Just use SOHCAHTOA. So this is going to be my opposite. That's going to be my adjacent. My r is going to be my hypotenuse. So I'm just going to use SOHCAHTOA. So sine is opposite over hypotenuse, so that's going to be 12 over hypotenuse is 13. Cosine is going to be adjacent over hypotenuse, so adjacent is my 5, hypotenuse is 13. And tan is going to be opposite over adjacent, so 12 over adjacent is 5. Okay, but we're not done yet, because so if you, like me, use a positive value of 12, then we have to make the negative sign adjustments, because remember, this is in the C quadrant of the CAS rule. So if I write down the CAS rule on the quadrants, is going to be in the C quadrant, aka the fourth quadrant. So this means all the cosine ratios are going to be positive, but everything else is going to be negative. So this one should stay as positive, but whatever is not cosine, so our sine and tan thetas, they should have a negative that's attached. So you'll notice that everything that we're attaching a negative to, they're actually the ones with the 12s. So that's why if you use negative, going to delete that. Okay. So if you use negative 12, then you don't have to reapply the CAS rule again. Okay. But whatever works for you. So I used positive 12, so I just applied the CAS rule after. If you just use negative 12 as your y value, like we said here, then the CAS rule, you don't have to use it, but you can use it to verify, right? So after you use negative 12, is the cosine ratio positive and is everything else negative? So you can do that double check just to make sure that you have the correct answers. And another thing, is the question asking for theta? No, it is asking for the sine theta, cosine theta, and tan theta. It is not asking you to find theta. So don't go ahead and solve for theta. It is not asking you to do that. It's just asking you for these ratios. So once you have these, you're done with the question. Number 3, determine the exact value of sine 240. So it's weird because it says find the exact value, but this one is not 30, 45, or 60. But maybe it is. So first let's draw it and find out. I'm going to draw my Cartesian plane because that's how I'm going to draw my theta. So I have my X and Y. So remember, this is going to be 0 degrees. Remember, we're going to go counterclockwise. So it's going to be my 90 degrees, 180, 180 degrees, 270 degrees, and if I go full circle, then that's going to be 360 degrees. Now 240 is going to be in between 180 and 270. That's why it's going to be in the quadrants 1, 2, 3. It's going to be in the third quadrant. So it doesn't matter, it doesn't have to be exact. I'm just going to put a random point in the third quadrant. And I'm going to draw a line from the dot to the origin. And we know that this angle is going to be 240 degrees. Now, obviously, it's kind of hard to find just sine of 240. So we're always going to use our related acute angles or our beta angles. And I'm going to draw my triangle. And remember, we always draw our triangle with the vertical lines, or you can also draw it to the x value, the x-axis. And when we have that, we know that this is going to make a 90-degree angle. And here, what will be my beta? So in order to find my beta, let's just do beta. So beta is going to be, so this is 240, but I know that that's 180. So if I do 240 degrees minus 180 degrees, that's going to give me the beta angle. So 240 minus 180, this is going to be 60 degrees. So that's going to be my 60 degrees. Where do I label that? Let me label that in red. No, I'm going to do this. 60 degrees. So if I just look at this triangle, I'm going to have a 60 degrees, which means it is going to be a 30, 45, or 60. So I know I can use my special triangles. And when we use our special triangles, then we can get our exact value. Okay. So I'm going to use my 60-degree angle. Once we know that this is going to be 60 degrees, we can come up with the ratios, right? So we know that this is going to be 30 degrees. You don't have to label that if you don't want to. If you need to, then that's great. If you don't need to, then that's fine. And let me label the three sides of the triangle. Whatever is across from the 60, we can also refer to this triangle. Whatever is across from the 60 is going to be root 3. Across from the 60 is going to be root 3, and the hypotenuse of that is going to be 2. So let me start by labeling across from the 60 is going to be root 3, and the hypotenuse is going to be 2, and the other one's going to be 1. So I got my ratio for the 60-degree triangle. Now it's asking for sine of 240. So this is going to be the same as sine of 60. So first we're going to find, well, what is going to be sine of 60? So sine of 60 is going to be, now if this is my angle of reference, that's going to be opposite from, the root 3 is going to be my opposite. 2 is going to be my hypotenuse, H, Y, P, and beside it is going to be my adjacent. So sine is going to be opposite over hypotenuse, so it's going to be root 3 over 2. So sine of 60 is going to be root 3 over 2. But it's asking for sine of 240. So this is where we have to look at, well, which quadrant is it in? And this is when we use the cast rule. So remember, our value of the ratio is going to be the same, but it's the sign, whether it's positive or negative, that's going to be different depending on which quadrant it's in. So let me write out the cast rule. So we start from down here, we have CAST. So this shows that whatever has a tan ratio should be positive, but this is sine. So therefore, sine of 240 is going to be root 3 over 2. So the number is the same. However, because it's in the t quadrant, it's going to be negative. Okay, so sine of 240, the exact value of the ratio would be negative root 3 over 2. And that's my final answer. Okay, I think this is the last question. Yes, it is. Number 4, determine angle theta when theta is between 0 and 360, and if tan theta is going to be negative 4 over 5. So we're going to determine our theta, and it gives us the tan ratio. So I'm going to start by drawing my Cartesian plane. I'm going to draw my x and y. And it gives it the tan ratio. So we know that if we're working with ratios, we're going to start by writing out our CAST rule. I'm going to do that in a different color. Okay, so CAST. Now we're going to look at, well, it says our tan ratio is going to be a negative. So remember, tan is going to be positive in this quadrant, in the A and the T quadrants. But it's negative, so it must be in the S and the C quadrants. So I'm going to have my two triangles in the S and C quadrants. So I'm going to have my point over there and my point over there. Okay, and I'm going to draw my triangle. Remember, again, draw it with a vertical line or draw it towards the x-axis. So I have my two triangles, and it's in the negative, so it's going to be in the S and C quadrants. Now determine our angle theta. So remember, theta, we always start from the positive x-axis and we go counterclockwise. So that's going to be my first theta, and my second theta is going to be this one. Okay, but before we can find what they are, we got to find our beta angles. So let me just label this beta, B, beta. Okay, and it's going to be 4/5. So because we already took the negative into account by putting it in the S and C quadrants, I'm just going to take just the positive values. And we know that tan is going to be my opposite over adjacent, because according to SOHCAHTOA, it's TOA. So that's going to be my opposite. So 4 is going to be opposite, 5 is going to be my adjacent. So let's look at this triangle to start. I have my beta opposite, which is going to be the orange line. That's going to be a value of 4. My adjacent, that's going to be the green line under it. So this value is going to be a value of 5. We can do the same thing for the other triangles. So again, the green, so not the green line, the orange line, that's going to be my opposite. That's going to be a value of 4. Adjacent is going to be 5. Now, we can try to see, is this going to be an exact value? No, because we have values like 4 or 5. And if you recall the special triangles, I'm going to scroll up. The special triangles, they have values of 1 to √3, and we also have √2. Ooh, that does not look like 2. And we also have √2. So it's only when we have these values that we know that we can have special triangles with degrees going to being 30, 45, or 60. But because it's not any of these side lengths, we know that we have to estimate them. Okay, and for me to get the beta, I always just take the positive value of 4 and 5. So if I want to find the beta, I'm going to do tan inverse of positive 4/5. You can do negative if you want, like the negative. However, if you do the negative, then it's going to either give you this one or this one. So you have to like try to figure out the beta afterwards. But if you just take the positive, it will always give you the beta. Okay, so I'm going to take the ratio, make it positive, so I can get the beta. Okay, so let me take my calculator. I'm going to do inverse tan 4/5. Make sure you use brackets when you're doing inverse tan, and then bracket 4 divided by 5, and then close the bracket, because if not, then you're doing something else. So my beta is going to be, it's going to be rounded, which is fine. 38.66 degrees. Okay, so my beta is going to be 38.66 degrees. Now we got to actually find our theta. So remember, our first theta, again, we always start from the positive x-axis. X-axis, I'm going to go into the first purple line. This is going to be, let me label that theta. It's going to be 180, and then you have to minus the beta. So my theta 1 is going to be 180 degrees minus the beta, and my theta 2, so my second theta is going to be, again, from the positive x-axis past the first terminal arm to the second terminal arm. So that's going to be my theta number 2. So it's theta number 1, theta number 2, and this is going to be a full circle, which is 360 minus the beta. So theta 2 is going to be 360 degrees minus the beta. And we know the value of beta. So all I'm going to do Now it's just sub in the beta values. So 38.66. And the second one, 360 minus 38.66. And I'm going to solve for those values. So the first one's going to be 141.34 degrees. And the second one is going to be 321.34 degrees. Now, the question doesn't really indicate what to round it to. Usually for degrees, I'm okay with you rounding it to either the whole number or 1 or 2 decimal places. What I just want you to avoid is any rounding that you have to do like in between the steps. So usually when you state degrees, like in the final answer, 2 or 1 for degrees, it's fine. Usually when I want you to find, it's like the ratio that I want you to find, usually those ratios. So like for example, if I say find sine theta, right? So the answer here, when we answer the ratios, these ones, I want you to have 4 decimals. Usually, if you have to round, then usually 4 decimals is good. So this is what I want you to avoid rounding. But when you're rounding the degrees, you can round it to like the nearest 10th or the 100th. It's only when we talk about the ratios that I want you to round to 4 decimal places so that you have the most exact value as possible, or like the most accurate value as possible. Now back to this question. Number 4, determine the angle theta. Did we determine theta? Yes, we did. So that's going to be my first theta, and that's going to be my second theta. Covered that in. Okay. And usually, like when you're done, I usually check my answers. So how do you check your answers? Well, this theta should go in here and it should give you -4/5. So usually I just do the little check. And you don't have to do this, like you don't have to write it down. I would just do it for yourself. So I would just do tan of 141.34 and see what kind of value do you get. So let me try. So 141.34, and I get a value of -0.80000. So if you round it, you get -0.8. And let's do the second one. So tan of 321.34. Now let me put this into the calculator. So if I do tan of 321.34, I get, again, -0.80000, and then some more numbers after. But I get this kind of number. And let's see, is this equivalent to -4/5? Yes, it is, because if you convert this to decimals, you get -0.8. So, so when you do the check, you might, it might not come up as the exact decimal because we rounded. However, you should be getting a value that is pretty close to -4/5. So that's how you can check your answers. And just always, when you're done, just go back and make sure that you are getting those values. Usually, like when I'm doing a test or a quiz, even for stuff like number 3, you can also check your answers. So usually what I do is I just take sine of 240 and I put it in the calculator, and let's say you get a decimal value, and if I put this in, I get a decimal value of approximately -0.866, and it continues. Well, see if you can get the same value for this. So if I do -√3 divided by 2, and I get a decimal value of -0.866, well, you know that you have the correct answer, or they should at least be correct. Okay, so hopefully that was helpful in preparation for your test that's going to be held over the next 2 classes. So we're going to have the review and then we're going to have the 2 test days. So please work on as many questions as you can before you come to review, which is going to be next class. And there I'll address like any questions you have. And if I can get to more of the test, I will try to give out more hints, like as much as I can. Okay, so hopefully that was helpful. If you have any more questions, please bring it to class, and remember to work on the questions before you come to class on review day, okay, because that's the day to ask me questions. So hopefully that was helpful, and happy studying.